This is video number 2 for section 9.4 in your textbook. This is number 72 from page 680. Paraphrasing the instructions, what we need to do are to write the first 6 terms, then identify the sequence as being linear, quadratic, or neither. The formula they're giving us is a recursive formula. They're telling us a sub 1 is 0, and then a sub n is equal to a sub n minus 1 plus 2n. Right, typically what your book does is it has the subscript of k plus 1, k. This is just an alternative way of describing the same relationship. The a sub n, whatever term you're looking for, is equal to a sub n minus 1, the term that came before it. Not a big variation. Okay, what is kind of a big variation is the fact of the number of the term is acting as a variable in the formula. And that's something I don't think we've seen before, and if we did see it, it wasn't anything that was emphasized, it was kind of glossed over. So, how do we generate the terms of this sequence? Alright. Comparing this to the previous example, we are beginning with a sub 1 as opposed to an a sub 0. They're specifically telling us that. So when n is 1, a sub 1 is equal to 0. Now when n is 2, what we're going to do is start with the formula a sub n equals a sub n minus 1 plus 2n. So we're looking for a sub 2. So if that's a sub 2, a sub n minus 1 is a sub 1 plus 2 times, and then the n for this particular term is the 2. Well, we know a sub 1 from the previous step. That's 0. Plus 4, so a sub 2 is 4. Okay, now we move to n is equal to 3, starting with the blank formula. If n is 3, we're looking for a sub 3. That's equal to a sub 1, which is one term prior to that one, plus 2 times the number of the term is 3. Well, we know a sub 2 from the previous step. 2 times 3 is 6. Our third term is 10. For n is equal to 4, that means a sub 4 is equal to a sub 3 plus 2 times 4. The 4 is the term we're looking for. That's 1 less than that. That n is the number of the term. We know a sub 3 from the previous step, plus 8 is 18, etc. is 5. Or n sub 5, rather. The instruction said to find the first 6 terms. I ran out of space here, so I did not find the 6th one because my paper was not big enough. So the sequence we have, we can add in that 6th term here to be thorough with the instructions. The next term would be 40. So we're concerned whether this is linear, quadratic, or neither. So these are the first 6 terms of our sequence. Checking the first order differences. We have plus 4, plus 6, plus 8, plus 10, plus 12. If all of those numbers were the same, this would be linear. That puts us back into section 9.2. This is not linear, so the next thing we look for, do we have a constant second order difference? In this case, we get plus 2's across the board. So that confirms that this is a quadratic sequence, and that's all they ask us to do for this particular problem. If we needed to, we could pick 3 of those values, put them into the calculator, run a quadratic regression, and actually get the equation for this particular sequence. That's what we did in the previous video, but for this particular question they did not ask us to do that. And then once we have an explicit equation, we can find any term we want, which again they didn't ask us to do, but it's a very valid follow-up question or a very valid point of the question where you'd have to do this stuff first and then get to that.